Hello and welcome to the Open Systems Media eCast Best Practices for Continuous Testing of IoT Products. I'm Kurt Schwader, your moderator, with today's speakers, Andrei Babulovich and Ron Mader from Ayla Networks, and Hardik Patel from VOLANSYS Technologies. Andrei is the lead software engineer at Ayla Networks. He has over 15 years of experience in software design and tests for Datacom and IoT. Andrei is currently focusing on QA automation for the device team at Ayla. Ron Mader is the lead software engineer at Ayla Networks. He's worked with software QA for 13 years at Dell, Amazon Lab, and various startups. Ron's expertise includes creating automation frameworks, QA tools, end-to-end tests, and most recently has been doing cloud performance work. Hardik Patel is lead IoT product engineering at VOLANSYS Technologies. Hardik is responsible for defining connected product engineering strategy to implement next-generation IoT products for customers across multiple industries. His history includes experience with multimedia, wireless, hardware engineering, and, of course, IoT. Today's schedule consists of about 50 minutes of presentation, leaving 10 minutes at the end of the hour for audience Q&A. Before we begin, I'd like to run down some important features of your viewing console. First is the Enlarge Slides button. This button will maximize the slides to fill your entire screen. The Download Slides button allows you to download and print the slides if you'd like a hard copy to follow along with. The button labeled Forward to a Friend enables you to send an email to someone that will include a registration link to this eCast so they can also attend. The Ask a Question text box enables you to participate today. You can simply type your question into the box and submit it using the Submit button. You can submit questions at any time during the material. We encourage you to do so early and often while you're looking at it in the question and questions fresh in your mind. We'll address as many of these as we can during the closing Q&A, and if you have a question pertaining to the eCast operation itself, you could submit those too, and one of our technicians will be happy to respond to you during the eCast. This and all Open Systems Media eCasts are copyrighted and may not be recorded or used in any way without the express written consent of Open Systems Media. Andrei will be kicking things off today. Andrei, the floor is yours.
Hi, everybody. Before we start this webinar, I would like to introduce Ayla Networks, which is one of the companies behind this presentation. So Ayla is an enterprise B2B software platform as a service for the Internet of Things. And our goal as a company is to remove as much friction as possible for our customers when it comes to building connected products. Comprised of three primary components, Ayla Device Agents, Ayla Cloud Services, and mobile application libraries, Ayla's Agile IoT platform provides a complete solution to connect nearly any device to the cloud and applications while offering all of the tools and premium services needed to manage, provision, and analyze their Internet of Things deployment. Ayla removes the need to invest in networking stack development, end-to-end security, cloud infrastructure, and other undifferentiating IoTs might have when bringing connected products to market, allowing them to focus their resources on their areas of expertise where it matters. So let's move to the next slide and talk a little bit about the topics of today's webinar. So let's start our webinar devoted to the continuous testing of IoT products. Today we'll focus on Homebridge, product by VOLANSYS, which is Smart Home IoT Gateway, and which is based on Ayla's IoT platform. During this webinar, we will look at the different testing areas, either from the platforms or the products perspective, to describe their techniques and to show how they complement each other. We will start from the brief overview of the end-to-end IoT ecosystems of the Smart IoT Gateway. Then we will continue with the overview of the IoT platform and we'll introduce its test framework. After that, we will move to the overview of the product and discuss the testing components, challenges, and approach. And next, we will talk about four major areas of Homebridge testing: device, cloud, mobile, and end-to-end, from either the products or the platform's perspective. And in the end of this webinar, we'll summarize the benefits and best practices of the continuous automated testing. Let's move to the next slide. So This slide actually represents the end-to-end IoT ecosystem of the smart home IoT gateway. It collects the readings from the attached sensors using various wireless personal area networks protocols. The gateway processes these readings and converts them into the data points, which are then passed to the IoT embedded agent residing in the gateway, which sends them to the cloud over the secure Wi-Fi connection. After the data points reside in the cloud, the platform makes it available to configuration and monitoring utilities using the REST API and to the mobile applications using IoT mobile libraries. In addition, the cloud can make its data pipe available to the supported cloud-to-cloud applications. This slide illustrates the separation of functions between the IoT platform and the product. Let's look at a little bit more detail at the platform. To better understand the scope of IoT platforms testing, let's take a more detailed look at it. As I mentioned before, the platform consists of three major system components. The connectivity module, which is the transport component, which basically interacts with the customer's application and sends the data to the cloud. The cloud, which acts as the service in this case, and the mobile applications for the end users. There is also a factory service to provision IoT devices during the manufacturing process, and various UI utilities providing the visibility and control for the cloud, and support for cloud-to-cloud communication. The diagram shows how the system components interact with each other over the communication links, which are secure, reliable, and designed to reduce the latency of cloud communication. The device and mobile components are presented by the families of products. For example, there are three different solutions for IoT device implementation, which differentiate by the level of support and flexibility given to the customer. Each solution supports a number of hardware communication modules and various ways of communication with the customer applications. For example, for the black box, customer application communicates over the serial channel SPI and UART using the serial protocols, while in the white box, it provides the embedded libraries for the customer solutions. The platform also provides the development framework for the customer in the form of mobile SDKs, embedded libraries, and demo applications. Summarizing the platform overview, let's list the important features and how they affect the test process. So three major features of the platform which are important for testing is its integrity, flexibility, and complexity. So the integrity means that rather than the separate components, the platform owns the communication system for the secure and reliable data delivery, storage, retrieval, and processing, which moves the testing to the system level. Also, it allows to design the system by tuning the components of communication channels in the most optimal way. So the second feature is the flexibility, which allows to support multiple products. And so the platform covers the wide range of features, which geometrically increases the volume of testing. And the last feature we talked about is the complexity, because the major system components are drastically different and require a different development and test environment. Let's look at the IoT platform testing with a little detail. So for this particular slide, we'll be focusing on the module, and later on, Ron will be presenting the cloud testing in more detail. The continuous testing often linked to the reduced development cycle, which is definitely true for the IoT platform, where we have the feature releases every 2 months and hot fixes every 3-4 weeks. But the other factor, which is as important as this one is the high cost of failure. So the only solution for the test approach is much closer integration between the QA and development, moving testing into the early stages of the development, deploying as much automation as possible, and using parallel execution. For example, our module regression runs about 1,000 automated tests for 34 various platform combinations. With an average runtime of 6 hours, it constitutes about 6 days. And to reduce this time, we run the regression on the test farm against all the platforms simultaneously. To run the automation, the firmware should have hooks for the configuration, control, and login, which could be collected by the test scripts from the module's console. Crash logs capability is also crucial for debugging the failures. On the previous slide, we've seen the demo application designed for the customer's convenience. During the test, they're replaced by the test applications, controlled by the scripts which provide the required flexibility. The test applications allow mimicking various customers' devices. To provide continuous testing, the regressions could be triggered by Jenkins from pull requests and results automatically submitted for the test reporting. So from here, I will pass it to our colleague from VOLANSYS, Hardik, and we'll go to the next slide.
Thank you, Andre. So before speaking about end-to-end IoT product testing using Homebridge, let me tell you more about Homebridge. Homebridge is a smart home IoT gateway, which is an MCU-based white label OEM solution. Let me briefly tell you about some specifications of Homebridge. Having ARM Cortex-M4 CPU, this gateway has multiple RF connectivity, having Wi-Fi and Zigbee out of the box, and Homebridge is customizable for other RF protocols. It is already enabled for Ayla platform, and it is having Android and iOS applications readily available on App Store and Play Store. Moving to the next slide. In this slide, I would like to explain the Homebridge architecture. It has basically Silicon Partner SDK components, as you can see marked in light blue. On top of it, there are Ayla components both at a platform level as well as mobile app level, and it is leveraging Ayla MF architecture. And as you can see also in the diagram, there are various product features developed on top of these SDKs, which includes provisioning, rule engine, scenes management, and RF connectivity. Moving to the next slide. In the era of IoT, we have three larger components: edge devices, cloud platform, and mobile apps. And for a quality IoT product, we need to have comprehensive testing of each of these components. For example, we need to test RF connectivity, load and scalability testing needs to be done. If there is a rule engine involved, we need to test the rule engine as well for the smarter applications. A lot of certification testing needs to be involved, and many more. Also, it is very important that each of these components should function with each other in a very seamless manner. But the question is, where do we start? So, moving to the next step. So when we were building Homebridge and make it tested for GA quality, we have faced various technical as well as business challenges testing it. I would like to summarize the same here. First of all, it has good amount of hardware complexity involved. It has a very small MCU which we optimized to run a gateway on it, and compared to other product vendors which has been using the same MCU for the end device, it was really challenging. On business end, it gives tremendous value in terms of pricing and competitiveness. However, on a technical front, when we say such small CPU should be able to support 40 devices, it involves great amount of testing. Having multiple connectivity protocols and their conversations with such a small package, it adds more challenge. Also, there are various regulatory requirements to comply as well. We need to take care of security of data being transferred, as well as user privacy also needs to be ensured. On the business side, making IoT product involves a lot of deal, and it requires a lot of vendor dependencies. We need to ensure that we receive each of the IoT components with right quality and on time, as well as need to ensure that we have a full stack skill set expertise available in-house to make such a product. While development is ongoing, releases also comes at a very incremental and rapid fire pace. So testing releases also with incremental builds is also a challenge. In this particular deck, I wanted to cover the test coverage metrics that we used to follow. So to ensure the product test coverage, for Homebridge we followed an approach of preparing feature-based test coverage metrics. As you can see in the diagram, each feature is divided into requirements, and to fulfill each requirement, there are a set of acceptance criteria should pass to complete that feature. And for each requirement, we have set of test cases. So we keep track of the same for each feature, and when all the test cases are passed for that requirement, with all the bugs are fixed, we consider that feature as a feature complete. So over here we used a Jira dashboard as an innovative way and used in Jira Epic terminology to have a dashboard and track the feature status, where test cases is an issue type and all the bugs are linked to each test case are basically the test results. Moving to the next slide. So to get into micro level details of various testing needs to take care, let me walk you through a real use case scenario with the Homebridge product. Yeah, on the device front, in this particular slide, I would like to talk about IoT device testing part. As the IoT devices are expected to run 24/7 long term on the field, robustness of the hardware and firmware is very critical, and contiguous updates also should function in a very seamless manner. As well as in the multi-device scenario, with various connectivity protocols are involved, converting data from one protocol to another is also a key challenge to test. We need to ensure that we do various testing of devices to achieve that, and which includes hardware testing, power supply and battery testing, RF testing, which I would cover in detail in coming slides. Mechanical also needs to be tested in various environments. Device commissioning needs to be tested from seamless user experience point of view. OTA as well as device availability and load testing also needs to be done. So these are all various testings needs to be done from the device end. And over here, automated build and test tools has always been a key helping hand to do certain kind of stress testing here. So let us briefly look at them from the hardware testing point of view in the next deck. So here is an automated test setup scenario of Homebridge. As you can see, the modules of Homebridge device have been logically divided into two categories. One is hardware dependent code versus the other one is hardware independent code. Hardware dependent code would function vary based on the hardware setup change. So let's say when there are a number of devices and how the connection between devices gets changed, the code starts behaving differently. Compared to there is a lot of hardware independent code also involved in the box, which can be tested without actual hardware. So if you see the strategy here, on top of a regular code base, we introduced a conductor test code, and that particular code is injected into build, which helps us test various testing. As you can see in the diagram, from test server, a Python script logs into CLI via telnet or serial and runs that particular test code. For example, we want to test the discovery part. So what we do is we put a home bridge into ZigBee discovery mode to detect the end devices. Part of the same automated test case, test server asked test hardware to press the sensor mechanical switch and put various sensors also into discovery mode. As a result, test server checks the output of home bridge CLI for the amount of sensors detected against how much sensors we have put on the discovery part of the test, and from that it decides whether the discover test passes or not. Also, for doing a lot of load testing without an actual hardware, such setup can help create virtual simulated devices without actual devices being there. For example, we can create 100 virtual bulbs and do the load testing of end-to-end system, checking how cloud, device, and mobile function when this many sensors are detected. Okay, so this particular section is dedicated to RF and topology testing. So when it comes to deal with multiple RF protocols on the same device, we need to take a very special care. Like RF congestion should not affect the data traffic and throughput. Also, data routing should happen correctly through various nodes of mesh. We do a range testing for that, checking how long signal penetrates on a different power range in the light of sight scenario as well as in the dense environment where there are a lot of obstacles. For RF signal penetration testing, we also test outcome through walls, water, glasses, such kind of mediums as well. And when we have a smart firmware return, to ensure that in a dense environment, the device has picked up a right non-noisy channel. So we need to do the testing of that also. And along with it, there is a feature called antenna diversity, where there are multiple antennas are involved, and we need to ensure that firmware has picked up the right antenna based on the current environment and the situation of the environment. So we need to do the testing of that also. On the data routing testing point of view, we need to check that if one data path is stopped, there should be automatic connection to the another path, and data should route through another path. And also we need to check that when there are a lot of paths available, really the data is going through the shortest path. Also, there are certain requirements of certification testing, compliance to the RF standards. So that also we need to do. Over here, sniffer tools really help us analyze various information. So in coming slides, we would look at them. So this is one example of home bridge network topology. As you can see in the diagram, home bridge is acting as a ZigBee coordinator node. There are ZigBee routing devices in the network. For example, you can take it as a ZigBee bulbs that can work as a router, as well as there are certain devices that acts as an AND devices, which can be motion sensor or door sensor. Moving to the next slide. So this is an actual sniffer outcome diagram when home bridge is connected in a multi-device scenario. As you can see, there are a lot of alternate paths possible among this many devices. So it is a pretty complex routing to analyze and debug for the testing part. So these sniffer tools really help us here. And so with this note, I would like to pass the control to Ron from Ayla.
Hello, this is Ron. I would like to talk about cloud functional testing. So the purpose of cloud functional testing is to make sure that our REST APIs, which interact with the cloud through HTTP calls, are correct. So that means that the responses that we get back from the cloud match what we expect. So that corresponds to verifying the specifications. Another purpose of cloud functional testing is to detect regressions. So that means when we run our tests and we find a bug, then that is a regression. So we have an automated suite of hundreds of tests which test our REST API. Some of the challenges that we have with cloud functional testing are cloud complexity, multiple cloud instances, and continuous integration. So with regard to cloud complexity, one of the problems is that our cloud is very complex. We have several services. We have the device service, the user service, OTA, factory, and cloud-to-cloud streaming services. So each of these services has its own set of REST APIs. So collectively, there's more than 100 REST APIs that interact with the cloud. Then also we have 2 web portals that interact with the cloud. One of them is our dashboard, and the other one is our developer site. Another problem that we have is multiple cloud instances. So we need to test multiple clouds. So those include our staging cloud, which we use for testing internally, our developer cloud, which our customers use for developing their products, and then we have our field cloud, which our devices interact with. Going on to tools, our test framework is built on top of Python's unit test framework, and we use Node as our test runner, and we use the Python request library to interact with the cloud using HTTP calls. Some other tools that can be used are Java and TestNG. These are equivalent to Python with unit test. We also use Selenium WebDriver to interact with our web UIs. We also have log inspection tools which help us diagnose failures in the cloud. Jenkins is used for continuous integration testing where code changes trigger tests to be run. So on the solution side, we have a test framework composed of REST API tests. The tests are data-driven, and we have scenarios that are rather complex to set up, and then we execute the HTTP REST API under test. We construct the input to the REST API and verify the response. There are different types of tests, including API, negative, integration, and end-to-end tests. There are also cloud UI tests. These tests include automated UI driver tests, which are organized in a page object model. That separates interaction with the web page from the actual code that logically executes it. Cloud UI tests also have input which interacts with the UIs, and then we verify the output. Going to the next slide, this shows our cloud and interacting with our test infrastructure. So we have our test configuration database, which supplies our test configuration to our test framework. Our test framework is built with unit tests and nodes and our request library. And those interact with our cloud services, which I described earlier. Those interact with the cloud services through REST APIs. Our user interface tests interact with our Cloud UI through Selenium WebDriver. Also, we have our cloud logs, which help us diagnose failures from our tests through the cloud. And also, we have test reporting, and we record those test failures through a tool called TestRail. Next, I will talk about cloud performance testing. The purpose of cloud performance testing is to detect performance bottlenecks and prove scalability of our cloud, as well as find slow queries which might impact the performance that our users see. Some of the challenges to cloud performance testing include exponential scalability, shaping of the load, and continuous performance testing. So scalability is a challenge because we need to test a cloud that is multiple sizes increased from what we currently have implemented in our field cloud. So that those clouds are very large and require a lot of resources. We also need to shape the load. So that means taking the top transactions that interact with the cloud, and we model those in order to produce load that exercises our cloud. Some of the tools that we use are Gatling, JMeter, and New Relic. Gatling and JMeter are load generation tools. Gatling is based on Scala and built a data structure which is executed in parallel. JMeter is based on a UI which has various components which are executed. Threads are used to represent individual users or devices. We use a tool called New Relic to view the performance of the cloud. So this includes throughput, response time, detecting of slow queries, and the time and frequency of requests, as well as server CPU. We monitor those with our Cloud Performance Inspector. And I should also mention that we simulate millions of devices with our load generation tools. Going to the next slide, you can see that our configuration sees our load generators, which generate transactions through the load balancer to the VM cluster. The VM cluster are a large number of AWS instances, which are computers, which represent our cloud services. The VM cluster also interacts with our database, which stores our device information as well as our user information. We use New Relic to monitor our cloud and inspect the results of the transactions. Again, New Relic helps us understand how our cloud performs. With that, I'm going to hand it back to Hardik.
Thanks, Ron. So talk about mobile application testing. Compared to traditional mobile application testing, an IoT mobile application requires a specific type of attention. Largely it is because it involves interacting with the real devices. So performance matters to control those real devices. As well as from the user experience point of view, it really depends on how good and how easy the user experience is given to the end user. For example, how easy it is to commission and add the device to the cloud account. For example, if you have an NFC enabled phone and a gateway, You just step the phone to the gateway and it should add the gateway to the cloud right away. It should be super easy for user from the setup of devices perspective. Also, a larger system testing happens through the mobile app. So while doing the mobile testing, we need to capture the status of the cloud and the device as well, part of the end-to-end testing. Moving to the next deck. So as we talked about functional testing in details about each components, in this deck, let us cover the performance and security testing in the depth. In the IoT, in the end-to-end performance testing, as Ron already covered in respect of the cloud, we need to see how system behaves when number of devices increases. What is the latency to control the devices when there are so many devices on the cloud? And we have to also measure how this tiny device keeps running for the years on the battery at very low power consumption. On the security testing side, it needs to ensure data security at each component of IoT ecosystem, starting from data being stored on the device, as well as communication between device to gateway to cloud to mobile app. It really needs to be secure. And to ensure the security, we need to test access control, data encryption, OTA security, device authorization, network security, and consider many more such parameters. Also, we need to make sure that we maintain the user and product data privacy very seriously and ensure that each stage of the system that user data privacy has been maintained. So this is a quick overview of VOLANSYS automated test framework. We have built it around Homebridge. As you can see, it not only can test the gateway and mobile, it can also test the end devices using electromechanical test setup. As well as it can do the cloud testing as well using Selenium, as Ron mentioned. Talking about the benefits of this. So these are some of the benefits of VOLANSYS Automated IoT Testing Framework. So by reducing the need of the manual efforts, it reduces the resource requirements and man hours, and in longer run, it turns out reducing the cost of the solution. In manual testing case, user cannot do the stress testing manually. While in automated testing case, we can run simultaneous tests at a time and stress the system, which an individual user cannot do. Also, automated test keeps running can be kept running for 24/7 without any user intervention. So you can just make a release on the DevOps server, and the setup would pick up the last release from the night, and it can be kicked off manually. And when in morning, it just gives you a test report in your email box with the results of whether the tests are passing or not. So these test scripts are really reusable, has been made in such a way, and this can be leveraged from one product to another product, which really reduces the time and cost when there are multiple products in pipeline to be built. Moving to the summary slide. So here is the top five practices that we wanted to recommend from our side. So one is that having a comprehensive test plan in line to the product features, then effective test case covering all the IoT components, use automated test tools and simulators as much as possible. Very important to coordinate between different teams, developing various components get together, and using DevOps and contiguous builds and build an agile testing workflows around it is also very important. So on a concluding note here, I would like to briefly talk about VOLANSYS. Basically, we are a one-stop solution enabler having expertise in building end-to-end IoT products, starting from component selection, board design and bring up, firmware development, device driver development, and product quality testing. Along with it, we also have a software application expertise for desktop, mobile, and cloud computing platforms. We are headquartered in Santa Clara, California, and we are a team of 300 engineers. We have a team innovating advanced and disruptive technology solutions in the areas of connectivity, medical devices, wearables, multimedia, and others. And also we provide a product leverage solutions that really helps shipping the products very quick. We're moving to the last deck. Here are some of the product leverage solutions which are already enabled with Ayla platforms that we have. Homebridge we talked about in detail. Over here I would like to touch modular gateway here, which is an IMX6 based flexible gateway. One can plug and play various modules with it, and it is already supporting a lot of RF connectivity, including Thread, ZigBee, and BLE. So we are an end-to-end system integrator and solution partner for Ayla. And as a technology partner of Ayla, we provide system engineering focusing on IoT, mobility, and quality. We are also partnered with leading semiconductor companies including NXP, TI, Marvell, and KVM. And in addition to those, we are also an active member of ZigBee and Z-Wave Alliance. So I think with this note, back to you, Kurt, for Q&A.
Great, thanks, Hardik. I want to remind the audience to click your questions, type them into the text box, and click Submit to enter those questions now. Let's move to the Q&A section here. Let's start with Ron. There's a question about a customer who's using Docker containers for their cloud applications, and they want to set up continuous integration for testing the scaling of those containers based on increasing and decreasing, client gateway traffic. Does the platform support that, or how would you recommend going about that scaling?
Well, that's a good question. We have not dealt with containers at Ayla, although we are moving in that direction now. So I can't really answer that question very well. Anyway, that's all I have to say about that.
Okay, but in terms of just being able to scale with traffic or devices, you can do those kinds of scaling tests in general for the framework set up that way?
Oh, yes. We have load testing, for example, that scales up to millions of devices, and we use that load testing to exercise our cloud and make sure that it performs well even at large numbers of devices.
Okay, great. Let's talk about REST APIs. I guess Hardik, you and Ron both mentioned REST APIs. In terms of the continuous integration strategies specific for equipment that might have different versions out in the field, is there any recommended way? Maybe we can start with Ron and move to Hardik to manage those, or to detect differences in the APIs and those kinds of things?
Okay. Well, if you have different equipment, that generally means that you have different configurations in your Jenkins server which can trigger the tests that apply to that equipment. So that means that the REST APIs that are specific to those pieces of hardware will be exercised. That's the best answer I can give.
Okay, so I guess you would create different Jenkins configurations for different versions of a product's REST API, just as if they were just different products themselves, and kind of manage it that way?
Yes, that's correct.
Okay. Hardik, do you run into any sort of versioning with the REST APIs, or even just versioning of remote nodes out there? that you've had to deal with
Yeah.
with your gateway?
Right. So yeah, if I talk about device specific, what we do is we generally have a local test server set up on top of it, and we have test scripts written that goes through cloud as well as locally for the automated testing of those all devices. So there are certain APIs has been developed that are routing through cloud, and there are certain APIs that would go directly to the device, and there is a small set of test scripts has been written on the device to help the device testing in detail.
Okay, great. Question relating to cloud performance testing. How do JMeter and Gatling differ, and which one do you recommend, Ron?
So sure. So JMeter is nice because it has a user interface that is graphically driven. So you create different nodes which represent things such as loops and individual HTTP transactions. And one difference between JMeter and Gatling is that JMeter implements one thread per user or one thread per device, although you can use a loop to increase that number. So that is a limitation of JMeter, which is pretty significant. Gatling, on the other hand, is a programming language-based tool. So it is based on Scala, and you build up data structures that are executed in parallel. Gatling uses an asynchronous HTTP library, and so Gatling can generate activity for a lot more devices and use our resources for CPUs rather efficiently. So if your uses are not as extreme and need a smaller number of devices, and you would prefer to interact with the UI, I would recommend JMeter. But if you have more ambitious goals, I would recommend Gatling.
Okay, great. Hardik, you had a lot of testing strategies that you had listed in one of your presentations. In terms of just general security or testing with respect to access, do you recommend any continuous integration tests for anything revolving around security, or even how to identify security issues with the device you're trying to test?
Yes. So from that point of view, from the device perspective, we ensure that our device has been provisioned with a certain user account, and so there is a particular encryption has been used between the cloud as well as mobile. So between cloud and device as well as between cloud and mobility. And from the device ownership perspective, there is a certain access control list has been maintained so that only those and those user accounts should be able to access and control those devices. From the data security, for the data being stored on the device side, we ensure that we store the data in an encrypted manner as much as possible. So if anyone is using the device also and getting the device also is not able to get into cloud, there is one-time registration only possible. So unless and until we reset the device registration from the cloud, once it gets manufactured and assigned to a certain user account or certain OEM ID, that device is dedicated to that particular product vendor and the user account.
Oh, okay.
So we take care of that.
Got it. Okay. Ron, there's an interesting question here relating to cloud functional testing. What are test plans and how can they be developed for the cloud?
Right. So test plans are developed from the specifications for our REST APIs. So what we do is we look at those specifications and we decompose them into smaller tests. Those tests basically are divided into input and output, and so we provide the input and make sure that the output works properly. But our tests are much more complicated than that and often require complex setup. So those setup steps are documented in our test plans as well. And well, that's basically it in a nutshell.
All right, great, thanks. Hardik, these gateways, I mean, they operate, I assume, over a wide area of kinds of network topologies like Wi-Fi or LTE or long-range radio wave. How do you consider different network properties and qualities of service and how to emulate them or test for them in your continuous integration?
Yes. So what we do is many times we have, so when someone makes a product, we have a control over the end devices that is being used in that ecosystem, or many times we don't have a control of end device that can be ready off the shelf. So what we do is we have a test bench setup which includes the end devices being controlled and being monitored by the sniffer tools, as well as the gateway, the homebridge gateway, as well as mobile apps and the cloud are part of the single test bench. So what we do is we and these antennas as well as the algorithms that run on homebridge for the congestion part of the network, that also gives us some data about the environment. So collecting the sniffers as well as the sensors on the homebridge part, we collect the input from every one of them, and we provide some configuration parameters to control this environment and generate an environment in such a way that we get a permutation combination and the test results gets acquired from various sources and then analyzed.
Okay, great. There's a really good question here. How do you recommend, Ron, how to scale their IoT testing when working with Amazon Web Services IoT or Azure IoT Hub? Can they use JMeter or Gatling for that to open many secured connections?
Sure. Yes, you can definitely use either JMeter or Gatling for that purpose. So let me see here. Yeah, so basically, JMeter and Gatling allow you to simulate devices and their interactions with the cloud, or users and interactions with the cloud. As I mentioned before, Gatling is good because it allows you to simulate a very large number of devices or users with using your CPU resources efficiently. So basically what we do with AWS is we have scripts for automatically scaling up our cloud, and then we apply the load to those clouds that we scaled up. And we measure their performance using such tools as New Relic to make sure that they scale linearly and the response times do not increase with the increase in size of the cloud.
Okay. Great, interesting. Hardik, you mentioned technology partnerships with the semiconductor manufacturers, which is a little surprising. I thought maybe it would have been with, IoT device manufacturers themselves. Can you explain the nature of that relationship, and maybe is it the development boards from these silicon manufacturers that maybe you can integrate with and do initial prototyping and testing with, or?
Yeah, sure. So basically, from the silicon partnerships point of view, let's say taking an example of one of the silicon partner, then we get a board as well as the base SDK from them, and a lot of time the cloud partner or we have been building a certain support package which has a lot of ready to use components. For example, we have provisioning is ready on board. We have features like okay, this many of RF chips has been already supported on this particular MCU platform. So those kind of integrations we have been getting it ready or getting it from the product from the silicon partner point of view, and then that particular thing is already built in. It really helps an end customer when they are going to make a product. They really get those base things are ready from our side, and we only take an effort of customizing or adding more features that are customized to a product requirement. So that way it really this SDKs from silicon vendor to the cloud provider to OEM provider like us really makes it very quick for the product vendors to make a product.
I see. Okay, so yeah, you can integrate a lot of the components or supported drivers or what have you for the embedded node or the sensor in the IoT. Okay, that's interesting. Let's see, Ron, what are the differences between smoke, sanity, regression, and integration tests? And how do you test them for cloud?
Yeah, so smoke, sanity, regression, and integration tests are different sorts of collections of tests that have different purposes. So the purposes of smoke, for example, is just to make sure that the very most basic functionality of the cloud is operational. And the focus there is on execution time, making sure that our tests are small enough or few enough so that the smoke doesn't take very much time. Sanity, on the other hand, is used when we deploy new code to a cloud. That new code has generally been already tested on our staging cloud, but now we want to make sure that all the pieces are running properly on the newly deployed cloud. Regression is our full suite. So that is used to make sure that the complete set of functionality that we have in the cloud is tested. And integration tests, those include both device, device, cloud, and mobile. So those integration tests make sure that those different pieces interact properly together.
Okay, great. Interesting. So unfortunately, we are reaching the end of the time for today's eCast. I want to thank Andre, Hardrick, and Ron for sharing your insights on best practices for continuous testing of IoT products. We at Open Systems Media, Ayla Networks, and VOLANSYS want to thank you, the audience, for attending today and contributing excellent questions remotely. This eCast will be posted online at the URL shown on your screen within 24 hours, and an audio-only podcast version will also be made available there. This and all Open Systems Media eCasts are copyrighted and may not be recorded or used in any way without the express written consent of Open Systems Media. Thanks for attending, and have a great day.